Hello and welcome to another tutorial for the NIH High Performance Computing Group. I'm going to explain how to use node local storage, or Lscratch, on the BioWolf cluster. However, before explaining Lscratch in more detail, let's briefly review all the storage options available on the cluster. Each user has an individual home and data directory. Files in these locations are stored permanently for as long as the account is maintained, and are accessible from all compute nodes, as well as Helix and the login node. The home directory has a small storage quota, is backed up to tape, and snapshotted frequently. Here is where users usually keep things like mail, configuration files, and source code. The data directory has a much larger storage quota which can be adjusted upwards upon request and is snapshotted less frequently. Files in this directory are not backed up to tape. This is usually where users keep active datasets for ongoing projects. In addition to these individual directories, there's also a large shared directory called Lscratch. Again, files here are accessible from all compute nodes, Helix, and the login node. There are no individual quotas within the Lscratch directory. However, Lscratch as a whole is limited in size. Files here are not stored permanently and at the moment are removed after 10 days of inactivity. Please do not write files to the Lscratch directory itself. Instead, create a subdirectory according to your username within Lscratch and use the subdirectory for temporary file storage and the like. So why would you want to use Lscratch? There are several possible scenarios in which using Lscratch may make your jobs run faster. For example, if you have a number of parallel jobs, all accessing the same file, or if you have jobs that access or create many small, possibly temporary files, or if you have jobs that do lots of random reads or writes or memory mapping. However, in all these cases, you should still benchmark your jobs to make sure that Lscratch really does provide the speed up that you expect it to provide. A final reason for using Lscratch is as a replacement for /temp. Some software packages default to writing large temporary files to /temp. However, on cluster compute nodes, this can cause problems. Therefore, we encourage users, where possible, to redirect such temporary files to Lscratch space instead. So now let's do a brief demonstration of how to actually use Lscratch on BioWolf. First of all, to find out how much Lscratch space is available on each of our compute nodes, you can use the freen command. Freen contains a column called disk that lists the total amount in gigabytes of Lscratch space available for each node. Now let's use an interactive session to explore how to allocate and use Lscratch. So as interactive, we'll start an interactive session, and to request Lscratch space, we say --gress equals Lscratch colon, and then the amount of Lscratch in gigabytes we need. In our case, we just request 1 gigabyte of Lscratch space. So now we are on compute node 1656, and if we look in the Lscratch/Lscratch directory, we can see that our job, which ends in digits 929, has been given a Lscratch directory. So our job has access to //163.289.29, and there's nothing in that directory. Now the easy way to refer to this directory is by using the environment variable slurm job ID, slurm job ID, which resolves to the same. So now, if we actually tried to create a file in Lscratch itself, we can see that we don't have permission to do that. However, we can create files inside the directory that was specifically created for our job. And now we can see that that file exists. Now, if we actually copy some data into this directory, so let's copy a test file that is 600 megabytes into our Lscratch directory. Okay, this takes a moment. Again, if we look at the Lscratch directory, we can see the file we just copied in there. Now, if we try to copy this file again, this is another 600 megabyte file, which with the file that's already there would make 1.2 gigabytes. Let's copy this to a different name. We see that this does not work because we exceeded the disk quota. So, because we only requested 1 gigabyte of space, we're only allowed to use 1 gigabyte of space. When I now exit this S-interactive session, this directory will be deleted and any files that were in it will be lost. So let's look at an example batch script which uses Lscratch. So in this batch script, we use sbatch directives at the top of the script to request 10 gigabytes of Lscratch space, as well as a certain amount of memory and CPUs. In this case, we're using Lscratch as a replacement for temp, or /temp, which is the default location for temporary files a lot of packages use. We generally don't want large files to be created in /temp because space there is somewhat limited. In this case, we request Lscratch and then we tell Java, which runs the GATK tools, to use /Lscratch /slurm job ID as the default location for temporary files. So we would submit this file with sbatch gatk.sh. And since we already requested all the resources as directives within the script, we don't have to provide any further options. To review, Lscratch space has to be requested at job submission and cannot be exceeded. At the beginning of a job, the batch system sets up /Lscratch /slurm job ID and gives the user access to that directory. At the end of the job, that directory, along with all its contents, is deleted. Therefore, any files required after a job finishes have to be copied to shared space, such as /data.